The objective of the work presented here was to determine the scale and distribution of pea sources and losses from fields in Scotland that can be transported to nearby watercourses and increase the risk of water pollution. For this reason, we developed a special assessment framework to map and quantify soil P export from cultivated land in Scotland, using available soil property and land use information for the two main transport pathways: a surface pathway that relates to particular P loss due to runoff and soil erosion, and the subsurface pathway that relates to P loss by leaching to artificial drainage systems. The special assessment framework was used to generate maps of harmonized estimates of P loss at 50-meter grid resolution for both pathways that were combined to estimate total P export from all cultivated land and assess the relative importance of the surface and subsurface pathways in the land that was assumed to be artificially drained. For the surface runoff pathway, particular P source was calculated by linking topsoil total P values from the Scottish Soils database under different vegetation types with field scale aggregated crop types from the Integrated Administration and Control System. We calculated mean soil TP for a period of 9 years to consider the effect of crop rotation. Then we related erosion rates with a land use intensity index we developed using iCrop time series as a proxy to intensity of cultivation and risk to soil compaction, and then the probabilities of soil erosion actually occurring in each 50-meter pixel were assessed based on their soil erosion risk class, and the erosion rates and the probabilities of soil erosion were combined to provide us with sediment yield, and that was combined with P source in order to calculate P loss as grams of P per hectare per year. The area that the location of where artificial drains have been installed in Scotland is unknown, so we had to infer this area by assuming that all cultivated land and soil with imperfect or poor natural drainage is actually drained. Total P concentration drain flow was calculated using relationships between agronomic P and ratios of dissolved total P to total P, as found in sample water from drains in grassland cultivated systems in Scotland. P concentration was converted to grams of P using the volume of water flow in drain, which in the absence of consistent estimates of flow in Scotland drain system was assumed to equate to all incoming winter rainfall. This process gave us harmonized maps of P loss in grams per hectare per year for the surface runoff pathway, for leaching to drains in the area assumed to be artificially drained, to total P export combining those two maps, and then for the relative importance of the pathways in the area likely to be drained. We found that P loss for the surface and runoff pathway was greater in areas that are being managed more intensively, as in land with reed crops in rotation. On the other hand, permanent grassland systems had greater P loss to drains because they are located at higher altitudes or in wetter areas than other land uses, and they receive greater rainfall totals, leading to greater estimated rainflow. Overall, the assessment of the relative importance of P pathway showed that P leach into drains was greater than P loss due to runoff and soil erosion for more than half of the agricultural land likely to have been drained, but P leach into drains was most important pathway of diffuse pollution in permanent grasslands, while for runoff and soil erosion, P diffuse pollution was greater in the area with root crops in rotation. So the risk mapping showed that runoff and soil erosion cause most of P loss in drier cultivated soils, while P loss through drains is the dominant pathway in improved grasslands on wetter soils or at higher altitudes that receive greater rainfall. These risk maps can be used by regulatory authorities to identify hotspots of P loss and potential transport to waters, and in consultation with farmers they can help amend cultivation practice and better target appropriate mitigation measures.